how do you call them, those brackets in English?
Left arrow. Left arrow, right arrow.
Yeah, something like that. Elements can be empty. In that case, we just put a slash behind the closing brackets. There can only be one root element, and usually XML doesn't have to be ordered. But if you use XPath and if you use XQuery, usually the elements are implied to have an ordering document order. This means that the meaning of A followed by B is not necessarily the same as the meaning of B followed by A.
What is the root?
The root tag is, for example, here the address element. There can only be one root element in a valid XML file. So and everything that comes inside are child tags, so the children and the parents. There's a hierarchical relationship.
But you can have another root after the first root?
No, only one. That's a limitation of XML. There can only be one root, but there can be a limitless number of children, and there can be, for example, multiple names and multiple streets and multiple numbers inside the address. But if address is the root of a file, each file can only have one root. Now, please ask.
Each file can be identification of one object which is outside the file. I thought root was the object, not the described object.
You can encode anything in XML if you want. It's just a textual representation which is formatted along XML guidelines, and those guidelines I've just presented. Now, MusicXML is a file format for music scores, and is actually intended to bridge the gap between several proprietary formats that exist today. Finale has its own file format, Sibelius has its own file format, GNU Lillipond has its own file format, I believe. Every partition, every music score software has its own file format. So MusicXML kind of bridges those formats. It's an interchange format to allow a Finale file to be encoded in MusicXML and imported into Sibelius. This support is already quite widespread. Over 90 software products now support MusicXML, so it's gaining. It's at this moment the most important file format for partitions that there is, and that is able to be used in such a diverse realm of software products. It's developed by a company, Recordari, based in California, but it's open source, so to say, under a royalty-free license. So this is Hello World in MusicXML, and as you can see, this bunch of code actually encodes just that single note. The format itself is very, very verbose, contains a lot of information, so it also implies that the MusicXML file really quickly gets really big. I've run some tests, for example, with Finale encoding some files of mine. One A4 page of piano music quickly results in a file of 250 kilobytes, which is a real lot of text. 250 kilobytes of text, that's immense. I'm not going to stand still further with this. More information on the format can be found on the website of Recordari. Now, XML files can be put into databases, just like you can put data from, for example, a forum into a database. Now, there's a difference between XML databases and the databases that you know from website backends, which are relational databases. Relational databases use SQL as a query language. Data is flat, it's not ordered. You work with sets of data which don't have an order in between, actually. Data is also uniform. Elements of data in a table are all more or less alike. Now, XML data is different. It's structured, it's ordered. The query language used for XML data is XQuery. Data can also be very variable, and you can see this, for example, giving this example. I haven't written the query down, but for example, on a relational database, you can find bank accounts by some bank, And it will return a set of bank accounts with no order implied. Order can be any order you want. If you run an XQuery example and you find, for example, all things that have red color in an XML file, in an XML file, you can find all kinds of things. You can find the tag stop sign, which is red. You can find the tag apple. You can find a noise tag. Also, the complete contents of the tag are also returned, and so the output can get quite large as well. Those are things that have to be taken into account when you write XQuery examples for yourself. Now, XQuery is based on XPath. Before I can go to XQuery, I first must explain XPath. XPath is just like XML itself. It's a standard of the World Wide Web Consortium, W3C, and it's formally stated it transforms a document tree, which is just an XML tree, into a sequence of nodes, and it preserves document order. XPath implies document order. And it's used to describe location paths. It has two syntaxes, an abbreviated and an unabbreviated one. I will use the abbreviated one just for the reason it's abbreviated, it's much shorter. And there's a separate standard by W3C, a function library, containing about 100 predefined functions which can be used in XPath expressions. Now, for example, I think it's perhaps best if I can I write on this?
Yeah, but not on that one.
Okay. Yeah. Okay. If for example, I have, I'll try to be clear. If I have a book, I can have a book here, and it will contain a number of chapters. Chapter, blah blah blah, slash chapter. Ooh. My writing is horrible, I'm sorry. And another chapter until the book ends. Now, using that expression and running it through an XPath processor will return me a list of all chapters in the document. Using the square brackets, you can do selections. I can select chapter 3. I can select section 2 of chapter 3 if there's a section here, for example. I can also define constraints on, for example, attributes, which are denoted by @ or the element contents themselves by extracting them with the string function. This is, for example, a query returning all sections that have something to do with Megabindi or that are written by Studio 100. More on this quick tutorial, you can go to the website of the World Wide Web Consortium, w3schools.org. There are some tricky things about XPath which make it a little bit difficult to use if you're used to, for example, SQL. One of those things are existential semantics, which is a real pain in the ass to encounter. Actually, the equality sign doesn't check for equality. It actually makes the intersection and it checks whether something on the left-hand side occurs in something on the right-hand side. So I can check for any number to be 1 or 2 or 3 or 4 or 5 using the first expression. If I do want to test for an exact equality, I have to use the EQ operator. I cannot use the equal sign.
Could you write 3 to 3 equals 3 to 3?
Yeah, the 2 operator generates a list of anything. You can so generate lists of from 1 to 100. It's really useful if you have a list of different numbers and you want to check if they're inside some range, for example. Document order also makes intersect and union operators behave a little bit tricky. If you make the intersection of 1 to 3 and 1 to 3, it will not be equal to the intersection of 3 to 1 and 1 to 3, for example. Just because the order is different, this will return 1 to 3. This will return either 3 or 2 or 1, depending on the implementation. So those are things that have to be taken into account. Identity is, you can check for identity using another operator, the is operator, but elements are only identical if they have the same location paths. Location paths that can be defined like this, for example. Now XPath is, you can do queries using XPath, but it's not very handy. You have to write your XPath expressions all in one line, for example. There's no support for functions, there's no support for recursion. And actually XQuery extends XPath by introducing, for example, functions, modules and namespaces, support for recursive functions, and most important, support for what is called the flower expression. I'll give you an example of a flower expression right here. You can do actually this more or less the same in SQL. You just go searching in a for loop for some set of elements. You can select them, you can order them, and you return them in any format that you want. Only the return clause is mandatory. You can nest queries, and the queries can be statically evaluated, which means queries are not run just through the processor. First you can compile a query and then do some transformations, usually graph transformations on them, to do some automatic optimization on your query before you submit it to the system. Comments in XQuery are denoted between those smileys. So yes, have some fun when you're a computer scientist. Now, music score databases, there exist quite a few. The most important one until quite recently was the International Music Score project. It's dead at the moment, but it is rumored that it will start again in July or August this year. It contained at the time about, I believe, 10,000 or 15,000 partitions in PDF form, if I'm not mistaken. Several others exist using PDF, but PDF is not usable to use XQuery on. You need XML data if you want to use XQuery, if you want to extract data from XML files. Mutopia uses Lillipond formats, which can be converted to use XML. Gutenberg has some partitions, but that's not really under development. And then I actually ended up with Wikifonia, which is also based in Ghent, I believe. And uses a wiki-based business model. Users can upload partitions, music scores in MusicXML format and edit them afterwards and download them for free. And they have quite easy access to the database as well. To test everything, I used the Exist XML database. It's an open source project based in Germany. It's written in Java. I consider it as a plus point because the reference implementation of XQuery is actually written in Galax, which is quite a strange language. It's actually written in OCaml, I'm sorry. The reference implementation is Galax, the Galax software, and that's written in OCaml. I really didn't want to get started with learning OCaml, and I know Java, so I just opted for Exist. It has a really good coverage of the XQuery standard, up to 99.7% of the whole standard is now supported. You can extend it with your own functions, either in XQuery or in Java, and it can be used as a website backend. The website of Exist itself runs on an XML database and is actually completely built using XML standards. So there's no PHP, there's no SQL behind it. And it actually has quite the same functionality as any PHP or SQL run website has. Downsides, yeah, it's written in Java, which doesn't make it really fast. Is not the big problem, but the memory footprint of running this is really large. And it doesn't support secondary storage. All processing is done in RAM memory, and there's no support for disk storage of temporary results at this moment. So if you really have huge databases, of thousands of files, or if you want to run queries which generate a lot of results, you either need a huge amount of RAM memory, or you need to find other databases which have support for memory. There's a good one by Microsoft, there's also one by IPEM, I believe, but those are of course expensive.
What's your benchmarking about what amount of memory are you talking about?
Well, I have put the settings for all my queries. I've needed to put the limits of memory on the Wikifonia database. The database itself consists of about 30 megabytes of data. It's not really much, but for running the query I had to put the limit on 512. I had to allocate 512 megabytes of RAM to the Java virtual machine to run all the queries that I will present to you.
Okay.
It wasn't still not enough for running the mining queries, so there I got a little stuck. So downloading the database, it's quite easy actually to download the Wikifonia database. I first did it with another query, but this is a more cleaner one. This is one which can also, which will output if there's no document found. Is there a pointer? No. Is there a stick somewhere? Never mind. You can see there the URL.
You can use the mouse maybe, or is it difficult?
I have got my mouse here, but okay. Got it. Great. This URL here. Oh, not scrolling. Actually contains the location where every XML file on Wikifonia is located. And it's just numbered by numbers from 1 to 1000 at the moment, because there's about 200 files in that.
Yeah, something like that. 280. Yeah.
I'll run it later in the database now. It's actually just a file one, which quite surprised me that Wikifonia didn't use a database as backend, but just dumped it on some kind of FTP-like file and just generated download links after. To be able to use XQuery, you need to put the documents in an XML database. So I just downloaded the whole database. It took me about 15 minutes using this. And the result, yeah, I'll show you the result. I'll need to start with the database, I hope. Live demos are tricky. I hope that everything will work. Okay, put it there. That's the database setup.
So you have to load the whole database in memory to do the query?
Yes, if you run queries on the whole database eventually. But I don't know how exist internally works. I believe that it's possible to use it file by file and run just file by file a query and combine them afterwards. Mm-hmm. But that's internal stuff of the XQuery processor of exists, so I don't know at the moment how it actually happens. So running that query leaves us with this. This is the complete Wikifonia database. And this is, for example, one of those. This is one of the partitions. It's Blanche et Impair by Willem Vermanderen. It's created by Sibelius, having a Proxy Music plugin. And yeah, this is the URL. And the whole file itself is quite long, as you can see. So you really don't want to go scrolling in by hand and searching for a specific node, or searching for, and certainly not searching for a specific rhythm, by looking at a representation like this. So what we do, we run queries. I'll go back to this and Great, I'll show you a few very simple queries. I'm not going to show them on presentation, I'm going to show them just in real life. It's a little bit interesting. I'll need to put the results count higher and I have to find them, of course, somewhere in research. I'll start with a very simple one. I can get, of course, all the titles from the database. Great, here they are. This is an extraction of all titles that are in the Wikifonia database. Of course, I can also count them and see how many documents there are. There are 227 documents in the Wikifonia database. Nice to know. This is, by the way, this is the database from 1 May, I believe. So it's not the most recent one. More interesting is, for example, which songs have the most notes in them. So there is a strange song which we will encounter later. It's some kind of Italian guy who wanted to promote his own music by just submitting it to the Wikifonia database, and he wrote some etudes with a lot of notes inside them. He has it, by the way, 2 times in the database. The song with the least amount of notes is the Scots tune, and it has 5 notes.
Is this different notes, or is it?
Well, yeah, it's just notes. It can be the same notes
5 times.
5 times. Anyway, it's just 5 different notes notated on a partition. I can get, of course, the songs that don't have any rests in them. Seems that there are a few songs which don't have any rests inside. Now, of course, Wikifonia stores lead sheets, not really complete partitions. So there's a difference between a complete partition and a lead sheet, in that a lead sheet only stores harmony information and the melody, and not the whole accompaniment, for example. If you were to search for pieces which have accompaniment, this would not return so much results. We can find the songs that occur multiple times in the database. Now this is handy, for example, to go looking for redundancy in a database, to go looking for covers of one song, or to go looking for plagiarism inside the database.
Title plagiarism then.
What?
Just title plagiarism.
Yeah, of course.
Which is not really.
No, okay, songs with the same title. Plagiarism will perhaps come later when doing.
It's probably possible, but I imagine the query is much
Yeah.
harder.
You're right. Same thing, we can go looking for authors that occur multiple times in the database. There's our Italian guy who submitted 12 of his own scores into the database. But there are 6 songs by Duke Ellington, 4 by Andrew Lloyd Webber, etc. Now it gets more interesting, of course, if we go looking for musical structure. Of course, if you go looking for author, you can also go looking for lyricist, publisher, etc. One thing that I found out is that the lowercase function, as it's implemented here, is really slow. So it took a bit. I had to rewrite my query later to get it done in appropriate amount of time. We can find songs by key signature, which can, for example. This finds all songs in C minor. The query is quite simple. This might be handy, for example, if you go learn the guitar, for example, and you only know a few scales, you can go searching for songs in that scale without having to browse through the whole database. seems that there are 6 songs in C minor, and the same way you can go looking for any key signature that you want.
But the key signature is declared
in the beginning of the file, of course. It doesn't check for modulations afterwards.
Yeah.
So if you go find for C minor and there's like F sharp major later, then that's not found by this group. But this is just a really simple example to show that it's possible. It is possible to go check for all chords that occur in each file and check and select based on the chords that occur in each file what type of complexity, for example. It could be a measure of complexity you actually want to find.
But the match is always exact.
A match is always exact, yes. So,
yeah, it's proven that, for example, names and titles are ambiguous in most of the databases.
Indeed, if you want to go looking for titles, for example, and I think I've done it in looking for multiple titles. No, it's not here. Is it here? Where is it? There's somewhere a lowercase function. I think I didn't include it here. But if you go looking for titles or authors, you really must watch out for example, for capitalized letters. If it starts with a capitalized letter, a string is different from another. So Beethoven with a small b in front is not the same as Beethoven with a big B in front. So for these things you have to do some transformations first, so to make sure that at least those things like capitalization or splitted words are filtered out or rewritten in some kind of standard form so that you can search for every occurrence without regard of, for example, capitalization. So that's why you need to use, for example, lowercase functions, but I cannot find it back in. Oh yeah.
One of the issues in music information retrieval is similarity matching. So you look for something that
it's still predefined.
It's not exactly the same, but that looks a bit like the same, and so there is a similarity matching, which is not a complete unification.
That is indeed, but that's way more difficult to solve using queries. You can write queries to take into account to for example, calculate distance metrics and compare based on distance metrics. But those queries really get quite complex. I'll present one later where I was searching for motifs and all kind of inversions of that motif, which actually implies that I have to consider all permutations of a certain note sequence, and this really gets the complexity of the whole thing, also the time complexity, going through the roof.
Yeah, so actually already the example you gave is a tricky one. Mr. Beethoven can be von Beethoven or van Beethoven.
Yeah, indeed.
You
have to know what you are looking for, and you have to.
But you can do partial matches, right? You just search for Beethoven, and then it doesn't matter if it's matches, van or.
There are matching functions which work like the matching functions in Java, actually.
Yes.
In XPath, but those work on strings, so they won't match. For example, if Beethoven is by accident not encoded in the author but in the lyricist tag, it won't find Beethoven as an author.
Yeah. Anyway, to solve this issue, the solution is to run a bot, a robot on Wikifonia, which is just fixing faults, like just trivial faults, like what's the right spelling of Beethoven. It's the same thing with Wikipedia. There are also bots on there which are just changing the data and making, correcting spelling faults and so on.
You can do some
so that will just solve the whole issue then.
Generating metadata to find the data more efficiently.
I have another question. What is actually the difference between this XML approach and this system developed by Nazy? He has a new standard I think, isn't it related to MPEG 7 or
MPEG 7, yeah.
MPEG 7, which is called Music Representation System, MRS.
SMR, yeah, I've heard about that. The problem with the format of Paolo Donesi, he used to work on the riddle music format in context of iMaestro projects. The problem with his format is that it's not adopted by the software community. So
by the industry.
By the industry, I mean, yeah. It's used internally in a lot of large projects, but and there are tools available, but there's not much content in this format.
What I have seen from it and what I understood from it, it seems to work in Max MSP. It's connected with
yes, there are plugins for Max MSP.
And they consider each node as a separate object, which is not the case actually in XML.
It's more or less comparable.
Yeah.
Each node is a tag, so a tag is.
The systems are comparable, indeed, but the reason I choose to work with MusicXML is because there's data available in the form of Wikifonia, and there's a lot of support by software and a real community, also from industry who are working on that. And indeed, parts of, for example, the experience of Paolo Donesi with riddle music are translated into the symbolic music representation. That's it, SMR's standard, which has been adopted by MPEG 7 or 21. I'm not really sure what number. But I don't know if those standards. It's just recently approved by the MPEG, the whole MPEG committee, and I don't know what impact those standards will have. I think it's too early.
But is it so that system is more more easy to connect it with a system like Max MSP, whereas this is more like related to let's say documents rather than systems that are interactive.
It depends, of course, what kind of software you use. I have used MusicXML quite successfully in combination with VST instruments, which is, I think, the same way that Max MSP can use riddle music using some kind of plugin. If your software supports, for example, generation of MIDI events from the MusicXML score, you can.
I think probably you have some tools for already developed for MMAX or PD. PD, I know that they are developing some.
Most MusicXML libraries at least support standards, things that you want to do to transform the data into binary data, like the MIDI format. So connecting with frameworks that use binary formats shouldn't be too much of a problem. Now I will say I haven't looked at all software that there exists. I haven't looked in detail at the tools that are provided for the MPEG SMR, because I actually had already made the choice to go for MusicXML because of the community and the large software support actually. In principle, it should be possible to convert this to SMR, or to convert SMR to this, and to run all these queries on file formats that are encoded in MPEG SMR. It's just a matter of encoding and translating between file formats.
Yeah, one of the advantages, because it's an open format, it's easy to write a converter to absolutely anything. Myself, I wrote a converter from MusicXML to a specific format I needed for my research in, I think, one afternoon or something like. It's very easy to write conversion because everything is open, as opposed to, let's say, Finale or Sibelius, which all have their own proprietary format, which is hard to open and to read.
Maybe in answer to your question, MusicXML has been developed starting from a problem from the industry. So they had sheet music made in Finale or Sibelius, and then they wanted to go over to another program or whatever, and then there was this need for standards. Whereas I don't know whether there's a real need for MPEG 7 or the other standards. This is probably more like a research
academic
thing rather than
maybe
a real need. No, I don't know.
No, MPEG you just slow.
Is to use scores in systems,
Mhm.
in interactive systems. I think like that.
But MPEG is an industrial standard, no?
Yeah, but the problem with MPEG is it will be alright in 20 years. It's just it's just how it works. It's a very
maybe it's going to
powerful
end up
organization which works very
like
slowly.
like NIF standard or XML old standards.
Yeah.
They're all dead by now, so we'll just have to wait, I guess. And in the meantime, do
If at some
research like
time,
this.
yeah, SMR has just been approved, I think from April this year only. If at some time, the industry picks up, it should be possible without too much effort to convert the whole Wikifonia database to MPEG SMR and include it into MPEG files. It could be a really interesting project.
I don't know
course.
if I'm wrong, but it seems that the main question inside the XML is that it declares its own structure inside the file. The XML it has the structure declared in the file.
No, XML is actually just a framework of file formats, and by the DTD, which is a separate file, you implemented the actual format, which is a specialization of the XML as a framework. MusicXML is an implementation which is specific to music, and that's written in a DTD, which you just so what the
so
makers
this
did
file
is
declares
make
the
the
structure,
DTD.
the
Yeah,
The DTD, yes, or the XSD or whatever.
in this case it's DTD. So.
But this kind of search is actually, what we would say, very low level. Last week we had here Florian Heilig.
I will also get AES convention in Amsterdam.
Okay. But he is just looking for this kind of system, but he will not be satisfied by the way you do this search, because he will say, oh, I want to search for a series of integrals, and not for the exact notes, for example. Okay? Because if you transpose melody, you are in monotonality. You have all the
I'll get back to that.
Okay.
First thing that I thought would be interesting is generating statistics for the database. This is the whole database ordered by time signature. So almost 50% of the database is in a 4/4 time signature, but almost 20% is in a wall-slide time signature. Those things can be interesting to search for. The same thing you can do with key signatures, where you see that most of them are in C major. The 0 and 1 and 3, that's the number of flats, negative or sharps, positive at the key signature. Going down, we see one song which has 6 flats and is in a minor mode, which should be about F flat minor, I believe. Something like that. I don't know. Something like that. So a very exotic time, very exotic key signature in music. So this is a really interesting one. Of course, we have now a library of partitions, but most of these songs contain lyrics, and you can extract the lyrics from the whole database. This will take a few seconds, but what this query will do is it will collect all lyrics from Wikifonia. Lyrics are encoded syllable per syllable in MusicXML, so it will extract all syllables, connect them where necessary, correct the intervention if necessary, and you can just use this to generate a lyric website next to, for example, your Wikifonia website. All these queries, of course, I present them now inside the database. You can put them on a website. You can make just a simple search page, like you have Google, for example, and type in. I want to search for this drop-down fields, this key signature, this time signature, generate a query from that, send it to the database and retrieve the results and format them in such a way that it's HTML and can be displayed on a website. So it's possible to just make a web interface for all this. This implies that lyrics are, of course, used the way they are to be used. And you'll, for example, see this guy, this Marafiotti again. He used the lyric tag to encode fingering. That's not the way to encode fingering. There's a special fingering tag to encode finger positions. He found nothing better than encoding the lyric tag. If you go looking for all lyrics, of course, then you get this whole list of fingering positions from that kind. So the user has the obligation, of course, to make it meaningful, whatever he encodes. If there's non-meaningful data inside the database, yeah, of course, whatever you get out will not be meaningful either.
It depends the editor, the software editor.
It's,
Probably
I
made
don't-
a software editor, and I did the same thing lots of times because it's too difficult to put numbers. Because I mean, Sibelius, you have to click every time. While if you put in with lyrics, just tap.
Yeah, of course.
So it's
if you do it wrong in Sibelius and you make lyrics in Sibelius, Sibelius will also encode it as lyrics. So it's a case of correct use of the tools.
Yeah.
Of course, the tools have to be made in such a way that it's handy to use them and it's not too difficult to add, for example, fingering or whatever.
He probably didn't do it consciously. He never thought about, oh,
Probably,
this is
yeah.
going to be written to XML where it's a right
Nobody
text.
encodes music and all
Yeah,
that.
that's true. That's what I wanted to
say.
say.
Some kind of
Use tools.
WYSIWYG editor.
Nee, dat is niks meer. Te lief wordt het eruit gesmeten. Dus als je niet ziet, dat hij het anders.
But, of course, the result, if
Het is
you
meer
go,
een piano partituur. Ik zal het niet direct nu op
Gewoon doen.
Uh,
Laat hem maar zo.
piano forte, dat is al veel. Die naar winkels staat erop.
bringing us to
Die twee, oké. Wat is goed dat er een keer uit en er raar op staat. Dat kan maar leren.
This can of course also be used. You can extract lyrics, but you can also extract harmony to generate tables of harmony, for example. A lot of software uses harmony or chord information, and you could extract anything.
What do you mean labels or from the chords?
From the chords, if it's encoded, there's a harmony tag to encode information about the chord that is being played.
Chord symbols.
Chord symbols.
Chord symbols.
Chord names
So
is,
you can extract them and generate, for example, tablature or put them in some format that can be used by other software to generate harmonies or to edit harmonies or whatever. So actually you can extract whatever is...
Can it be done for chord progressions? So let's say the 2-5-1 and for jazz and so on?
Can be used for chord progressions if at the moment if they happen to be right, if there's not too much space in between.
Yeah, sure.
If you want to go searching for chord progressions and at different times with every kind of variation in between, then the complexity just gets too complex. That's not computable anymore. You can find rhythmical patterns, and I believe that I will have to switch databases to use this. I've got two instances of the Wikifonia database, one in one big file and one with separate files. The big file has 750,000 lines. No editor, whatever editor can handle that. But I managed to paste it.
So what's the advantage then of keeping them not all in one file?
No.
So why do you do it?
Because that was the first time I downloaded it. I just dumped them all in one file because I didn't know already how collections worked in the database system. So I only knew how files worked, not collections of files. I'll have to use Great. I believe it's this. What I want to do here is actually look for rhythmical structure. I have just taken as an example a Blue Danube, famous waltz by Strauss. It has a really simple rhythmical motif, da, 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 like this. And you can go look for this motif all the way through the database. If you just find the duration of each note and you impose the constraint that the duration of the first note has to be equal to the duration of the second note, has to be equal to the duration of the third note, and the fourth note has to be 3 times the duration of.
But we need to be a programmer to be able to define it like this. If we would ask
yeah,
this,
but you can translate this into a web interface.
Mm.
I can make a very neat HTML form, and yeah, for example, add a note, define duration or duration in relationship to other nodes. This, for example, will not only search for this pattern, but also for if it's shorter. So it will just look at the relationships of the durations between the nodes. It will not look at the length of the node itself. And if everything is alright, the query should have finished. This motif occurs throughout the database. Of course, it's a very simple motif. Blue Danube is not the only song that contains it. And I can extract where, in which measure it occurs and at which note it starts. This could be really handy to go, for example, highlight those parts in a partition. That's something that you want to know. If you have a real large score, let's say the score of a piano concerto, and you have a rhythmical motif, yeah, you just search for it and have the computer highlight this motif throughout the score in any voice, in any instrument. It's, you don't have to go looking by hand for it. I remember my classes in music harmony, I had to go looking by hand for those things. Always you forget or you look over a few instances. You can just find all of them. And even find related ones, but in other, at another speed or in another time signature or whatever. If everything's fine, the Blue Danube should be somewhere inside any. Where is it? Come on.
Komt de loop.
Nou, dan is een meta-zoekactie doen. Zoeken in de zoekresultaten.
Yeah, the software is not really well developed. It's never mind. I assure you, it's somewhere in there. I know what I need to do. I need to increase the result count because there's more than 100 results, and I need to resubmit the query then. And then you'll see Ruben popping up somewhere. But if you now go to the website of Wikifonia, but I don't have
wireless
internet or I cannot connect to the network of the University of Ghent because I'm not a member of the University of Ghent. But if you go to the website now and you go check to this score a beautiful friendship and you go looking for measure 17 at node 2, you will find node 2, node 3, node 4 and this in the next measure, for example. You will find this motif inside that score and you will also find it in the score of a perfect day, in measures 10 and 18, etc. And come on, good and voila, there it is. There are several measures where you can find, of course, that is to be expected. It's the main motive of the music. It's to be expected that it occurs quite a lot. And also close to each other. In measure 318, 323, 327, you see it repeating constantly. You can do the same, of course, with melodic queries, but it gets a little bit more complicated when you go looking for melody. Actually, I just did the. I did almost the same for melody, but just now looking for. Wait, I'll write it here. If you
have some bars here.
Oh yeah, never mind. It's I'm sorry for my horrible writing. Voilà. Now there's a motif, a melodic motif that occurs until you get mad in Blue Danube, and you can go search for all of its instances in the database. Now the thing you have to do, you have to calculate the pitch of each note first, and then, as you see here, I can use not the definite pitch, for example C, E, G. I'm not going to look for C, E, G, but I'm going to look for an interval of 4 semitones and an interval of 3 semitones and an interval of 0 semitones here. So I can use it for any major chord in any scale that occurs anywhere in the database. And this way I can go find melodic motifs based on intervals actually. And if everything's alright, it also occurs in several songs, not only in Blue Danube. But for example, in this song for you, it starts at MIDI pitch 65. I cannot calculate MIDI pitches by heart, but it will be something like, anybody know?
69 is middle
60
C.
is C, middle 60 is middle C.
Oh,
60 is middle
oh, then it's
C.
A, yeah.
So this is
this will be
E.
This will be E. But a little bit further, you find, for example, starting at B or
D.
D65,
D.
F, and D.
This is D.
Or at another pitch. And of course, you will find it multiple times in Blue Danube. But even in Blue Danube, for example, starting at different pitches, indicating, for example, modulation. Also, this you can of course put in a web interface and make a nice HTML form, add a node, related this amount of semitones to the next node, etc.
What happens if your program contains actually chords rather than?
Well, yeah, chords are notated in MusicXML as nodes after each other. So if there are chords, this query won't be affected. It's just a chord is just a node with a chord tag inside, and this indicates that sequences of nodes are actually to be notated together.
Yeah,
but it still is a sequence of nodes in the file.
If you would have 4 times the same chord, so will we solve there?
Yeah.
Would it find this melody inside?
2 times the same chord.
4 times.
4 times.
Yeah.
It would not find the melody inside because the chords are notated node by node. And if you have, of course, 4 chords of 3 notes, you have 12 notes. And at this moment, the query is not able to take into account if there are spaces between nodes. So, can it? No. Yeah, I do work to make it all a little bit handier. I work with subsequences of nodes in which I'm going to generate lists, small lists of all nodes occurring next to each other in the file. But they have to occur next to each other in the file. So I cannot have, for example, a note here in with the flute and then an E here in some kind of trumpet, and then the violin playing a G a lot later and detect that. That's possible, but let me tell you beforehand, that's not feasible. That has a computational complexity of at least this and faculty, and as soon as you go searching for large sequences, this number gets blown up and it's really not scalable anymore then. So you could implement a query doing that on small files, or small databases, or with very small motifs, but it's really not scalable.
I think what he means is not in different instruments, but one instrument, for instance the piano, which plays 4 times C major, and in this query it wouldn't give a match, but if you ignore the chord tags in between, it will give a match. So I think the answer is not in this case, but if you want, you can make it.
Still, if you ignore the chord tags, it wouldn't give a match because it would be encoded as CEG.
Well, not
CEG,
ignore
CEG,
them, but
CEG, all in one list next to each other.
Yeah, I don't mean ignore them, but don't work with the order in XML tree, but convert it back to time or to ticks, how it's represented internally.
That could be done. Yes.
Just you have to match. See,
also
there's no time difference, but.
If you want, for example, to go looking for a C major chord, of course it doesn't have to be CEG, it can be EGC or
but yeah, the thing I just wanted to say, it's possible, yes or no, just what you want. It's all possible.
It's possible, but yeah, the problem is if you have a chord like this of 3 notes, there's 6 possibilities of note order, 3 faculty. If you have 4 notes, 4 note chords, that's already 10 possibilities. So you have to go looking for 10 possible instances of a certain chord.
I don't think so, but we'll talk about it later. But
I think that's a technical
it's too technical, but I think it's both possible. Just whatever you want.
I think it's possible, but not scalable. We'll discuss it later.
Okay. I think I did something similar, so that's why I think it's possible.
Now, what we have done? We have database statistics, we have rhythmical patterns, we have melodic patterns, which we can detect. I don't have to tell you what a motif is in music, but motifs, of course, are a core of music. Is that motifs get varied upon. The most simple way to vary a motif is just using inversions, which can be used to detect chords. Now, as I said, in XQuery, it implies an ordering on the data. So if you want an ordered list of notes to be converted to a set of notes, you need to take into account all permutations of that ordered list. Now, this is a query which generates recursively all permutations. I will not get into details of that. But actually, also, when we want to search for melodies, we need to take into account transpositions. You can have Cs in any octave that you want. So actually, you need to map all notes onto one octave, and then search inside that octave whether there's any chord existing. It corresponds very well to what's used in for example, chord detection methods in music information retrieval on sound recordings, where you use chroma beams and you go map the whole spectrum onto one octave and go see what frequencies actually are the strongest. This is a screenshot of one of the tools that is in the CLAM editor, which is developed at University Pompeu Fabra in Barcelona, which is one of the major open source music information retrieval software frameworks. So what do we use actually? We calculate the MIDI note number and we do it modulo 12, so we map it onto a range from 0 to 12, and we go calculating with that. I would show you that code. Yeah, I can show you that code. It works, that code. But I'm not going to run it because the query takes about 15 minutes to complete. And that has everything to do with this factor popping up. If you generate all possible permutations of a chord, you get a lot of permutations. You have to check for each sequence, is it any of these permutations? That's a real long computation. It's not scalable if you use it for large chords. I assure you that it works, but I'm not going to run it. it's still in need of a bit of optimization, and perhaps it will help you with it then. Great. Disadvantage of all these methods is you can only look for predefined patterns. You have to define what motif you want to look for first. You have to define rhythmics or melody, and then you can search targeted for that occurrence, for that motif where it occurs everywhere. It would be really neat if we could automatically, for example, extract those motifs that occur most often in a file. Now this is a problem that can be solved using data mining, but I'm not going, since we're already busy for more than 1 hour and almost 1 hour and a half, I'm not going very much into detail about that. Data mining, theoretical. Okay, data mining is actually concerned with finding frequent occurring patterns in data, whatever the structure of that pattern may be. There are several algorithms that exist to do data mining. Yeah, I just skipped the mathematical introduction to data mining. If you're interested in a mathematical introduction, I do refer you to the website of the ADREM research group of the University of Antwerp, and search for Bert Goethals. He has a really neat, recent state-of-the-art of data mining, containing an excellent introduction on what data mining is and what it means mathematically. There are several algorithms existing to go looking for frequent patterns. The first one developed is a priori. It's not very, it's not the most yeah, it is up to date. It dates from 1993. But it's not the fastest around. That's what I wanted to say. Better ones are ECLAT or FB Code, but a priori is by far the most famous because it was the first. FB Code is quite recent, actually. Those details about those algorithms are that's really computer science stuff. I'm not going to bore you with that. But a priori has been translated to XQuery in 2004. The code for that algorithm in XQuery has been published in their same paper. They had to do a few tricky things. For example, they had to rewrite the intersect and union and except operators. The reason for this is that intersects and unions working on sequences don't work the same as working on sets. Because you work with ordered items in XML, you cannot use you cannot use these operators as you would use them on sets. Now, sets. Unfortunately, data mining is defined and has been developed on relational databases. So all those algorithms work on relational databases. So if you want to translate those algorithms to sequential data, you have to convert, almost to convert the sequential data to relational data first, introducing this, taking all permutations into account, and that kind of, yeah, didn't work out very well. So, the problem is really more fundamental if you want to use data mining on XML data. You need, and that's a topic on its own, to develop mining algorithms for XML data. Mining algorithms that are made to work on sequences and not on sets. It requires rephrasing. What are we looking for? It requires new tools, etc. It's really, at this moment, underdeveloped. Actually, yeah, if anyone's still looking for a PhD thesis topic, I guarantee you it will be a blast in the computer science world. But the theory for mining XML data is at the moment still underdeveloped, and there's no, at least not that I know of, decent and fast algorithms developed yet. to find frequent patterns in XML data. But of course, yeah, to end with a positive note, scores at this moment are still, if they're used for information retrieval, like for example in Humdrum or toolkits, those use textual representations very often related to MIDI or using MIDI. Now MIDI is yeah, ancient, it's prehistorical, it's from the Paleozoic of computing. It's older than MIDI. But now that MusicXML is still being adopted, and MusicXML contains a lot more information. For example, information about slurs, about accents, about notation marks, about dynamics, etc., about tempo. MusicXML contains all this information encoded, which you will not find in MIDI and which are difficult to encode in Humdrum-like formats. Now you can very easily, using XML databases, using XQuery, find structures inside XML databases, using XML databases. So I think it has quite some complexity, quite some possibility for the future, if it could be integrated in for example, open source databases like Wikifonia. If a search interface, web interface could be developed that allows for good inputting of this kind of structures, translating them to XQuery, sending it to the database and displaying the results back. If it can be developed, it allows for a lot of possibilities for lay people to also do some kind of information retrieval on music scores. So,
and what have you developed here? Because,
actually, this was just a field test. Actually, it's more a proof of concept than anything else. I started with this after reading this paper of Viglianti, which stated that XQuery didn't support arrays.
Yeah, but it's just a matter of understanding. So you use this search tool, and you have developed the search scripts, or
yeah,
developed the tool
itself. No, I haven't developed the tools itself. I just used the database exists, the data Wikifonia, and I've just poked on a few queries, which I believe would be of interest for both musicological community and also for the music software community. Now, I'm not a musicologist myself. I'm not going to tell you what you are looking for. I need to hear that from you. What do you want to find in music scores? So I didn't really develop it any further than this, because at this stage I need inputs both from Wikifonia. What do they want from it? From you? What do you find it interesting? Do you want to do anything with it? Other software vendors, are you interested in extracting data from databases like this? Now I need more inputs to be able to develop more.
Quite convincing what you showed. It's quite powerful.
I think it's really powerful. And if the tools can be developed to do, for example, a simple thing like highlighting in a score, a certain melodic motif. I think it doesn't exist. It exists for years. We don't think even about it in PDF files, for example. But such a simple thing even doesn't exist today.
Well, we are working on it. So besides the musical information which is in MusicXML, we render on Wikifonia the PDFs, and by rendering it, we're using the Lillipond render for that, render engine. By rendering it, we know where the elements are being positioned on the score. So therefore, we have some kind of an XML which can say that element is being rendered there. So if you're saying,
I can just generate a list of elements and say, yeah.
And then it can be highlighted on the score.
Element number this in measure this.
Yeah, yeah. So it's nearby. I mean, it's just very close. Just have
you
to
do the same, but in a different representation. You use the Lillipond representation. You redo the queries or something.
We don't do the queries. We just want to make a mapping where we say this element is being rendered on that place on the score. So some kind of spatial coordinates, and therefore these queries can just display where the results are rather than some kind of a textual results.
Yeah, of course.
I think that's more powerful than the MusicXML, than just in your representation.
What do you mean by that?
I think that's, if you can query the text, it's much more powerful than using the Lillipond for the matching.
Yeah, but the Lillipond, we don't use Lillipond for matching. Lillipond is being used for rendering the scores. And then, of course, we know where the elements are being put on, so we know the spatial information. So if he has a result set, and we saw textual information on the result set, we can actually display it on the score where the results are, rather than just going through the listing.
But you need his input to do that, actually.
Sure.
Yeah,
that's why we're here.
Yeah, those queries that I've shown are really simple, and so you can use them if you want. Yeah.
Yeah, it's a pity that Florian is not here because.
Well, actually, that's why I taped it so he can watch the tape afterwards.
Ah, okay.
I think the big problem with this kind of stuff is that MusicXML is a notation format. It's a score format. Yeah. So most queries musicians want to do are more musical queries. For example, if you have two notes with a tie, two tied notes, they sound as one note, but visually they're two notes, and in MusicXML they're encoded as two notes. So that makes it a bit difficult. There's always the bridge between acoustic and visual stuff. So if you're looking in MusicXML scores, you will be looking for graphical things, for notational things, and it will be more difficult. What Florian wants to do is go a bit deeper in the more musically meaningful things.
The representation to the sound.
So I would suggest, well, this is good work, but most people that want to do information retrieval or something try to somehow extract musically meaningful features from the score and then do a search on those features and not on the score level. But of course this is useful.
What I remember,
for things like tight notes, those are indeed encoded also in XML, but you can make in your query an exception for tight notes. For example, you can leave out all notes that have tight, which indicates a tight note. And that way you eliminate the ties, and you can do the same with chords. You can eliminate chords, or you can require chords. You can search for notes that are played together as a chord.
Wouldn't it be better to make a kind of filter that goes from score representation to musical representation?
Yeah, sure.
That's what I actually wanted to say, that MusicXML is not just a format which represents the notation, but can also represent in the same file how it sounds like. So it's more than just, it's actually a replacement for both things like Finale, which represent the visual view, and MIDI. So it's
but that doesn't happen very often. We don't have many examples of music. In principle, there you could put MIDI information, etc. in, but it's not used very often. It's just a promise from Michael Good to do it, but it's I think the MusicXML, the hierarchical representation is just not very suitable for complex queries like looking for vertical patterns in multiple voices, etc. So, but this is very good for going from left to right in one voice, and of course you can make whatever exceptions with ties and chords. That's right.
The query is of course more complicated. It all depends on what you want to look for. Some things are really easy to encode in XQuery. Those small melodic fragments, it's just not more than 10 to 20 lines of code. That's peanuts. That's nothing. If you really want to go looking for more complex things and take exceptions into account.
I think that's the power of this approach. You don't need any other representations. You don't need software converters. Just do the query on the XML. That's a good thing, because it's the interchange format. So you could go deeper, but it would take more effort.
Of course, you can construct queries dynamically if you use a web interface.
But the musician will not maybe have the time to learn how to encode the queries.
No. That's why a web interface.
It needs an interface.
With the web interface, he will always ask something that is not in the web interface.
But that is also the problem of Florian Heyrik's thing. He wants to make possible every query, and maybe that's a bit too much.
Well,
in der Beschränkung zeigt sich der Meister.
It's the same thing we happen to have with Wikifonia. When we started, we want to be a repository for sheet music, all sheet music, but that wasn't possible. I mean, as well as Mozart, as for instance, just lead sheets, and then of course we had to just focus on something, and we had to eliminate all the full scores or piano arrangements or whatever, and just focus on lead sheets, and that was in some kind of a way for us all some kind of a drawback. So we thought, okay, we want to be the repository, but okay, we ended up with lead sheets. But we started, and we ended up right now with 280 files, which is not much, but we are running. And therefore, you're delivering the data to him, and it will go on, hopefully. So, the web interface, it just is probably not that difficult. So
it's not difficult, but I'm not going to put mine.
No, sure, okay.
I need to get
That's
on.
normal.
This is a side project, so it's actually gotten out of hand. It's a little joke gotten out of hand. Trying to prove this Vigilanti guy wrong, and I have to quit here. But I'm really willing to start up collaborations and perhaps go develop something
more
on a broader scale.
Yeah.
But now I cannot go further on my own. It's, I would do things that are not wanted or not required, and yeah, that's useless.
Not paid, mostly.
And probably not paid for doing it.
That's what comes down to. Somebody needs to write an interface, and nobody's going to do it for free, probably.
Students.
I don't have
thesis project.
I have students.
It's just too late.
Yeah, great.
It's just too late. We have to wait a year.
Well,
waiting for stupid
in the hogeschool is
Okay.
I have another, maybe if I may, another about the data mining. I think the patterns you're looking for in music are always, in some sense, not always, but mostly will be ordered. For example, in time. But data mining, if I understood it correctly, is more about sets, so no ordering. So you're always saying, yeah, we have to take into account all permutations. But I was just wondering, can't you just leave the order, which is a good thing, and take ideas from data mining, but make your own algorithms?
The problem is that data mining, the algorithms shown a priori and ECLAT, they use some kind of growth algorithm. So first they go searching for single elements. Do they occur often? If they occur often, we go looking for combinations of those elements. So they make an intersection. And just this intersection operator doesn't return always the necessary results. So the algorithms are defined on sets and work on sets.
So maybe you can find another algorithm that, for example, taking the growth. So you find single elements, and then you try for example...
to tell you honestly, I'm not an expert in data mining. I've searched for a while, and I've asked the people at IPEM that they're not really busy with XML. I found one recent paper indicating, we are going to do this and we're going to do this, but of course this doesn't help me further.
Yeah, I think that's a good thing, to talk to the people and say, this is my problem, and does your algorithm map to this representation, because it's hierarchical, so I think
I'm
not sure about this.
I don't know myself very much what I actually want to find in this course. What I want to find, combinations of nodes, but do I take into account rests? Do I take into account base nodes? Do I want to find combinations of rhythms? How does it all relate? I mean,
if best is to work with real users, with the people from the conservatory, for example.
Yeah.
To make an exercise.
So I'm not going to start working on something if I'm not. I don't know what I'm doing actually.
Mm-hmm.
So to develop it further, I need more information, more input from others, and I need collaboration with somebody who's doing PhDs in data mining or something, because it's not my topic. I've had a few courses, but they don't help me much further.
Yeah, I also have a question which I don't exactly know about a lot myself, but how well can you use it with fuzzy sets? Maybe if that's a solution to work with the similarity-based measure if it's a fuzzy set. But I also had one course in fuzzy sets. So
Actually, I have.
You also had that one course.
Yeah, I think it would be. That's similar to using distance metrics, I believe.
I know, well, I don't know personally, but there is at least one person working here in Ghent at the Sterre on fuzzy sets related to music.
Mm-hmm.
Data mining can be used using fuzzy sets. And that's the concurrence metric.
Mm-hmm. Ja. En Timmer?
Giflody.
Is vorig jaar
Is
nog
het
meer
nu
geweest?
naast de Vemme?
Ja, ja.
De stage naast de Vemme.
En zijn naam kwijt.
Ik heb zijn naam kwijt. Ik heb nog nooit gezien. Ik heb zijn webpage gezien.
Fuzzy sets, we also have contacts with our colleague D3.
Guy de Drie.
Ja, dat is ook Elis, maar... Nee, bij aan de Voskeslaan geloof ik. Bij de wetenschappen is het dan niet ingenieurswetenschap, maar de wetenschappen.
Maar dat is kern.
Dat is kern.
Ja, ik weet niet wat dat is, kern.
Kern.
Dat is een naam.
Professor Kern.
Fuzzy logic.
Ja, nee. Dat is te doen, ik weet het niet.
I don't know much about fuzzy logic myself.
Okay, so thank you very much for the presentation. Next meeting, do we have a next meeting already?